Hello, friends. So I hope you can see this okay. Let me pause this for a split second and try closing these blinds. Well, there you go. That's darker, creepier, but better. All right. So we're working on planetary shadows right now and how to calculate those. We're going to use this formula, and maybe I should rewrite it over here where you can see it more easily. And it's L is equal. L is the length of the shadow times R, the distance of the body casting the shadow from the light source, times the radius of the body casting the shadow, or the occluding body, one casting the shadow, the occluding one, which is dark and creepy now, isn't it? All right, divided by the radius of the light source minus the radius of the occluding body, or R of O. Now in the solar system, that radius of the light source is always going to be the same number, right here, because it's the radius of the sun, 695,500 kilometers. It's a simple calculation. And it's one I want you to practice so we can get more used to using numbers and thinking on these scales as we start to talk about solar system mechanics. This is kind of our ease into it for next grading period. So here's number one on the homework assignments. All right. First, I want you to write everything out like this. We're going to look at Mercury's shadow. And the distance from Mercury to the sun is 57.9 times 10 to the 6 kilometers. That's the semi-major axis, or the average distance. The radius of Mercury, the occluding body, the one casting the shadow, is 2,440 kilometers. And again, the radius of our light source, 695,500 kilometers, the radius of the sun. Fair enough. So, let's scooch it just a bit here. Now we're just going to plug our numbers into our equation. Pardon me. No death, I promise. We take our distance from the light source times the radius of the planet. And then we, on the bottom part of the equation, we take the radius of the light source and subtract the radius of the planet. Please always make sure you set up your equation first with the numbers in it. Don't try and just jump right to the answer. That way we can both see where mistakes might be made, little things like I made mistakes in this one. I was off a whole power of magnitude. It was rough. I can't believe I missed it again. So when I calculate these numbers, I get 1.41276 times 10 to the 11th kilometers squared. And make sure you carry your units through. Always carry your units through. Units are essential in astronomy. Numbers are just adjectives. Units are our nouns. We want to be able to describe the distances. Then, when I subtract, I get 693,060 kilometers. 1 kilometer here, kilometers by kilometers here. One of these cancels one of those. So we know we just have kilometers left. Perfect, because we're measuring a distance. Always check your units. So the length of Mercury's shadow, when you take this number divided by this number, we get 203,483.823 kilometers. Clever. I love this stuff. It's so much fun. That's how long that shadow is from Mercury. So with our light source here, the sun, Mercury's shadow is going to be conic shaped and super long. Isn't that neat? So cool. So here are the numbers I want you to use. That's right. Come with me. Here's the distance for each of the planets that you're going to calculate. Mercury, Venus, Mars, Jupiter, and Saturn from the sun. Notice they're all in millions of kilometers. That's how we prefer to measure things. That's the unit we like to use for distances in the solar system. And then here's the radius for each of those planets. Again, in kilometers. Now for the moon, you'll notice I put 2 here, because for question 6 on the homework, it asks you to calculate the new moon, which is the Earth distance minus the distance to the moon, because the moon is towards the sun, or 384,400 kilometers closer. And here, at full moon, it's the other side of the Earth, or 384,400 kilometers away from the sun. That much more. Plus the 149.6 times 10 to the 6th kilometers that we're already at on average. And then here's the radius for the moon. Using all this information, try and calculate the 6 problems that are posted for today. It's weird. This is weird making videos, guys. Honestly, making videos like this, kind of weird for me. You can see my face. It gets cut off. I don't know what I'm talking about. I feel real goofy than normal. So, yeah. Here you go. Here are your numbers. Try your best with it. See what you can do. Tomorrow, on the 30th, Wednesday the 30th? Yeah, Wednesday the 30th. We have a Google Meet at 3:30. I'm going to post about it again. I put an announcement up already. Watch this video and then come to the Google Meet tomorrow. Work on this assignment. Hopefully, I'll see you then. Good luck.